In this lesson, we'll be discussing the rate of change. At the end of the lesson, you should be able to find the rate of change in a real-world context and use this rate of change to solve problems. So rate of change is just how one quantity changes in relation to the other. It's the same as slope. So we take the change in quantity, which is on the y, over the change in time, which is on the x. There are 4 types of slope. Positive slope slants up and to the right, and where the numerator and the denominator are both positive or they're both negative. So for example, when we look at this graph, it goes up and to the right, and my slope is either 2 over 3 or negative 4 over negative 3, because negative divided by negative is positive. We have negative slope, which slants down and to the right, and the numerator or the denominator are negative. So we can see our graph is going down, and our slope is either written with the negative sign in the numerator or in the denominator, or sometimes it's written in front of the number, which means that you can put the negative with the numerator or the denominator, but not both. 0 means it's a horizontal line, so it has 0 steepness, and 0 is in the numerator. And then we have undefined slope, which is a vertical line, and 0 is in the denominator. When 0 is in the denominator, it's not a real number. So we'll talk a little bit more about zero slope. We have this acronym here, it says HOY, HOY. Means horizontal slope is 0 and y is equal to. That's how we write the equation. So from a graph, we have a horizontal line. Looking at a table, you'll notice that all the y values are the same. From an equation, we don't have an x in it, we just say y equals. And then from the words, the dependent quantities are all going to be the same. And then we have undefined slope, which is VUX. So it's a vertical line, which is undefined, and the equation says x equal. So your graph, up and down line, your table, all the x values are the same. So when you write your equation, it doesn't matter what y is, x is always 2. And from the words, the independent quantities are the same. So let's do some examples. Find the rate of change and write the equation. So this first one, we obviously have a 0 slope here. So if I'm going to write the equation, it looks like it's going here through negative 3. So we'd say y equals negative 3. In this one, to find the slope, I'll do y minus y over x minus x. And that gets me negative 3 over 0. And when 0 is in the denominator, it is an undefined slope. For undefined slope, we write an equation, x equals negative 2, because it's here. The second one, find the rate of change from the table. The table below shows the number of students who majored in biological sciences in the United States during the years 1990 to 2000. So let's find this rate of change. This is going up by 6, as this goes up by 2. That means our rate of change is 6 over 2, which is 3. So we would say there is a 3,000 student increase per year. All right, and B. Again, we're going to try to find this rate of change. This is going down by 9, and this is going up 2. So my rate of change, or slope, is negative 9 over 2. All right, finding the rate of change from a graph. So looking at this, if I start here, then I'm going to go down to this one and right here. So that means I'm going down 10 and right 75. Uh-oh, nope, down 5. Down 10, which is minus 5. And then right from 0 to 75 is 75. And then that simplifies to negative 1 over 15. Let's look at B. So we've got 2 points here. Remember, it's a change in y over the change in x. So I'll use these 2 points, and 30 minus 25 over 100 minus 40, that's 5 over 60, which simplifies to 1/12. Find the rate of change. Mark is moving across town. He rents a trailer for his belongings for the first day, and it costs him $25. Unfortunately, he doesn't finish, and so the total cost for 2 days is $45. So 1 day is $25, and 2 days is $45. There's your 2 points. This rate of change is 20 over 1, so my rate of change is $20 a day. The function y equals 3.75 plus 0.15 times the quantity x minus 1 we can use to determine the cost in dollars for a taxi ride. What is the rate of change of the cost in dollars with respect to the number of miles? Well, this equation here is written in point-slope form, and here's your point. So, there's your slope. So your slope is $1.50 per mile. Eli burned 1,449 calories running a half marathon. If he finished the race in 2 hours and 6 minutes, how many calories did he burn per minute? So we're doing 1,449 calories per minute. So 2 hours, that's 120 minutes, plus the 6 is 126 minutes. When I divide these, because it says per 1, so I'll divide the top and the bottom by 126, and it comes to 11.5. So it's 11.5 miles per minute. Jade read 324-page book in 12 days, while it took her friend Mindy only 8. How many more pages a day did Mindy read than Jade? All right, so let's see. Jade read 324 pages in 12 days. That means she read 27 pages per day. Mindy, same book, 324, but only took her 8 days, which means she read 40.5 pages per day. So if we subtract these, we can see that Mindy read 13.5 more per day. So if we use this, and we're just going to match our slope to the graph. So we can see that this one here is a negative slope because it's going from left to right, it goes down. Then we have this one being 0 slope because it's flat. So it's a flat line, you're not walking up or down. Here's our undefined slope. And then this one is our positive slope because it's slanting up and to the right. Some more pictures of slope. So what is the rate of change for this one? Well, it looks like we're going up 15 here and up 1 here. So this one's up 15, so our rate of change is 15 over 1.